Here we are going to graph a number of natural logarithmic functions, starting with y equals e to the x, and using transformations. We'll list the domain, range, and asymptote for each function. The first function is f of x equals the opposite of e to the opposite of x. So we start with y equals e to the x. We then graph y equals e to the opposite of x, and finally y equals the opposite of e to the opposite of x. And so y equals e to the x is increasing through quadrant 1 and 2. It passes through the point 0, 1. It also passes through the point 1e. When we replace x with its opposite, we reflect across the y-axis. So across the y-axis, and then when we take the opposite of the function, we go across the x-axis. So across the y-axis, it'll now be decreasing through quadrants 1 and 2, still goes through 0, 1, and then when we reflect across the x-axis, the curve will be increasing again, but through the third and fourth quadrants, going through the point 0, negative 1. Each time our domain is going to be negative infinity to infinity. Our range this time is negative infinity to 0, and the asymptote is y equals 0. 0 is not included in the range. So for our second example, we'll be looking at y equals 8 minus e to the x. I've temporarily lost my cursor, so I hope you'll bear with me there. So y equals 8 minus e to the x. So we'll start with y equals e to the x. We'll go to the opposite of e to the x, and then we'll add 8. That is the same as 8 plus the opposite of e to the x, or 8 minus e to the x. So first of all, we'll reflect across the x-axis, and then we'll go up 8. So start with y equals e to the x with 0, 1, the y-intercept. Across the x-axis this time, so we'll have a decreasing function in the third and fourth quadrants through the point 0, negative 1, and when we move this up 8, what was 0, negative 1 will be 0, positive 7. So the domain would be negative infinity to infinity, the range negative infinity to 8, and the y-asymptote y equals 8. In the second example, or in the next example, we have y equals e to the opposite of x minus 1. So we start with y equals e to the x. this time go to e to the opposite of x, and then subtract 1. So, starting with y equals e to the x, we'll go across the y-axis, so this leaves the y-intercept unchanged at 0, 1. And then we'll go down 1. So 0, 1 will now end up at the origin, and the horizontal asymptote will now be y equals negative 1. So domain, all reals, range negative 1 to infinity, not including the negative 1, y asymptote y equals negative 1. The next one is a bit easier because it's f of x equals e to the x minus 1. So we start with y equals e to the x, and then we replace the x by x minus 1, so we'll go right 1. So we start by knowing that the y-intercept is 0, 1, and when that moves to the right 1, it will go through 1, 1. So the domain is negative infinity to infinity. The range is 0 to infinity, not including the 0. The y-intercept is still, or I'm sorry, the horizontal asymptote is still y equals 0. It's not changed when we reflect across the y-axis, or when we move right or left. So the next example, y equals e to the x minus 3, quantity plus 4. Start with y equals e to the x. Go to y equals e to the x minus 3. And lastly, add 4. So first of all, we'll go right 3, and then we'll go up 4. So here's our 0, 1. Going right 3. So we'll make this 3, 1. And then we're going up 4. And so instead of this being 3, 1, it will be 3, 5. Domain, negative infinity to infinity. Range, 4 to infinity, not including the 4. And horizontal asymptote, y equals 4. The next one is h of x equals e to the x plus 1 minus 5. Rather similar to the last one. We start with y equals e to the x. We replace x with x plus 1. And then we subtract 5 from the result. So we'll be going left 1 and down 5. So what was at 0, 1 will now be at negative 1, 1. And then when we move down 5, it will be at negative 1, negative 4. So the domain, negative infinity to infinity. The range, negative 5 to infinity. And y equals negative 5 is the horizontal asymptote. And our last one, g of x equals the opposite of e to the x minus 1 minus 3. And so we have y equals e to the x, then y equals e to the x minus 1, then its opposite, and finally the opposite of e to the x minus 1 minus 3. So we go right 1 across the x-axis and down 3. So start with 0, 1 as the y-intercept. When we go right 1, we'll have 1, 1. When we go over the x-axis, we'll have 1, negative 1. And when we go down 3, we'll have 1, negative 4. So the domain goes from negative infinity to infinity. The range goes from negative infinity to negative 3, not including the negative 3, and the horizontal asymptote is y equals negative 3. Now, I'd like to verify that that point 1, negative 4 is on this graph. So g of 1 would be equal to the opposite of e to the 1 minus 1 minus 3, which would be the opposite of e to the 0 minus 3, which would be negative 1 minus 3, which in fact does give us negative 4. So in the complicated ones, it's kind of good to check.